Hey everybody, this is Larry. This is day 23 of the December Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. And of course, my background is a little bit different, as you may notice. It means that I'm in Panama, where you can find the palindrome, which maybe a lot of Leetcoders may be familiar with, which is man, a plan, Panama? I don't know. Also, I'm getting a race car. I'm just kidding. I'm not getting a race car, but I am in Panama though. And today's problem is course schedule 2. If you want to see what I'm doing in Panama, just follow me on Instagram. The link is somewhere. You have the technology. Anyway, all right, let's take a look. Course schedule 2. There are number of courses, okay, 0 to n minus 1, given prereq. You must take okay, you want to take, so, okay, B sub I is a prereq for A sub I, okay. Return the order of courses, if there any impossible, okay. So this is just a very straightforward topological sort. Straightforward if you recognize it, or straightforward if you have, there's no nuance to it. It is just topological sort. And if you're not familiar with topological sort, definitely feel free to study it and so forth. Okay, so there are two ways that you can think about topological sort or implementing it. One, the way that I usually like doing it with breadth first search, kind of. I don't know if it's breadth first search, but a queue-based solution maybe is a better answer. And there is a recursion-based solution, which is, you can also think of it as a stack-based. The way that I differentiate them, and some problems is more intuitive to do one, and sometimes more intuitive to do the other. But for this one, I think either one is fine. Basically, the idea behind the Q one is the way that I think about it. The differentiation. The Q one is basically asking yourself, okay, I have all these classes. What class can I take next, right? Which is usually any class that doesn't have any prerequisite. A stack-based one is kind of the other way, right? Of, okay, I want to take this class. What classes do I have to take first? So that's basically the idea. The differentiation. I don't know how I want to do, and I'm too lazy to do both because I am in Panama. So I don't know how. Not gonna lie, my video quality may be a little bit dubious in terms of explanation, but we'll see how that goes. I actually usually do the queue-based one, so today let's mix it up a little bit and do the recursion one, though I think that's the more popular one, to be honest. So again, the idea behind the recursion one is just asking yourself, okay, I want to take this class. Take this class. What classes do I have to take before that, right? So first we set up the prerequisites in a way that allows us to access it much easier. So I'm just going to call it, let's just say prereqs. Of a list, and then now for UV in prerequisites type. So U requires V, right? Okay. So that means that in order to take a U, you have to take V. Okay. And then now, let's also say N is equal to number of courses, though, and then maybe just done is equal to force times N, right? And then now the idea is that, like we said, for each class, we try to take each class for I in range, in range sub N, and then let's take this class, right? Just make sure that, okay. Okay, I just want to make sure that I am, this is 0 indexed. So, okay, so then now, basically if not done of I, or maybe it doesn't, we can also just go, tick I maybe, I don't know. Naming things is hard, right? So then now we have an answer. Let's just say we have an answer variable or classes or whatever you want to call it. And then now we just take class, right? So let's say, okay, we want to take class X. Okay, so then that means that we want to take as prerequisite first, right? So if we haven't already, so that means that if done of x, then we just return because we already took the class, so why take it again? Of course, you can write it in a couple of different ways. For example, you could have gated it here and maybe another place, but maybe this is slightly easier. And then now for prerequisites in prereqs of x, we just take p, right, if we need to. And then now, once we take all the classes, right, now that means that we took all the prereqs, so then now we can take this class. So then we just append x, and then we set done is equal to true. And that's pretty much it, I believe. Yeah, let's give it a spin. Do keep in mind that the recursion based one and the queue based one may yield different answers. They're both when they're multiple answers, they may yield different answers, but it's fine because this one, it's you return any of them. But one thing that I did forget is that if it's impossible to finish all courses, return an empty array. So that is something that I don't know if it's in the thing, but yeah. And the only thing that can happen, at least the way that we set it up, is if there's a cycle, right? So let's see. Maybe I muck things up a little bit. Let's see what my thing would return. I don't actually, to be honest, I did not prepare for a cycle because usually they tell you that it's a DAG or whatever. But okay, so yeah, so this would go in an infinite loop because this isn't done. In that case, we have to find whether there's a cycle, right? And cycle detection is not that bad. Let me think whether I want to kind of put it into this or doing this, right? So I mean, yeah, okay. We can also just, in that case, we can add a thing maybe. I don't know if this works, to be honest. It's been a while, or at least like I know how to detect cycles, but I haven't think about it in terms of incorporating the one function. So then here maybe we can do something like, okay, processing of x is equal to true. Okay, if this is done, we return. Otherwise, if this is processing, then we also return. But instead, we want to be like, okay, there's a bad variable because it's processing, but it is not done, right? So non-local bad is equal to true. If bad, return to okay, and then so here we are processing, and I think maybe that's it. Yeah, let's see. I don't. Not gonna lie. Now I'm a little bit less confident, but basically what I'm doing here is saying, okay, if we're processing this, and we get to a recursion such that we're processing but it's not done, then that means that there is a loop somewhere because if this was a tree, if this was or not tree, but if this was a DAG, everything that is processed is either done or not done, right? If something is processing, that means that it loops back. You can also maybe use some what you would call it, like if you really want, you could kind of play around with some if you're familiar with bridge finding or articulation point finding, you could probably play around with the idea of the earliest like quote unquote earliest time you visit a node, and I think that would also essentially do the same thing. I don't, to be honest, I'm maybe not super confident about this, but let's give it a spin. I bet you last time I did it with breadth search though. Okay, so this looks good. But yeah, you can definitely use the bridge finding type thing as well with the idea behind that, you know, having a time, and you reach a node that that is earlier in the current process and there's a cycle or something like that. You can figure it out, I think, maybe. But yeah, let me take and this is going to be linear time because we only process each edge once, and yeah, we only process each node once. So this is going to be all linear time, but linear time, of course, is, if I can get this out, O of V plus E time and space, we also is all v plus y because we reprocess the space. Yeah, so oops, and this is probably the lower bound. Let's take a look at what happened. Yeah, so I did do it the other way last time. So if you want to check that out, I'm sure I have a video. Someone link it below, or I'll link it below if you ask me about it. But yeah, that's all I have for this one. Let me know what you think. Hope you all are having a great, December and holidays coming up, or maybe already in it. That's all I have. Stay good, stay healthy, to good mental health. Larry from Panama, I'm out. Bye-bye.